reviewed parallel lines, and parallel lines are just lines that are never going to touch. So for example, this train track, right? Those are parallel lines. These rows, whatever farm this is, go Bills. We got the yard lines that don't touch as well. And then even in like a city, a lot of the streets run parallel to each other because they never run into each other. So thinking about which of these could be parallel, all of them could be. So those are some real world examples of parallel lines. So that's the big idea. They never touch. And there's one more thing that we want to talk about with parallel lines. So on a graph, these lines would run into each other, and the problem is they have different slopes. So if the red line is negative 1.5x plus 3, we want to have negative 1.5 as our slope, and then we'll get parallel lines. Doesn't matter, as long as it's 1.5, any minus 10, whatever the y-intercept is, it doesn't matter. These will be parallel as long as the slopes are the same. The only line you can't do is the exact same line, because that's the exact same line. It's not parallel. They're touching no matter what. Always going to be touching infinitely, so that's not the same thing. Those are the same line. We want to make it different, so let's just have a different y-intercept. So these are parallel lines. So the key idea is we always want to have the same slope, and then the slope is always just the number associated with the x value, right? So like 1/2 x, so 1/2 is the slope. So if this blue line is 1/2 for the slope, this orange line is also 1/2, those lines are parallel. Let's skip this and go to our notes. So equations of parallel lines always have the same slope. So the equation of the red line is 5/6x minus 2. In class, we just did a quick turn and talk. What is a possible equation of the blue line? And it could be anything that is y equals 5/6x. You could have plus 5, minus 5, plus 0, plus 10, minus 10. Anything except minus 2. So as long as the slope is 5/6, we would have a parallel line. So a lot of options there. So now we're going to write the equation of a parallel line that goes through a point. There's a couple different ways to do this, but it kind of ties back to what we talked about yesterday. So let's say I want a new equation of this line. I want to go through a point, and I want to have the same slope because the lines are parallel. So what really would be helpful is to use point slope, because we're talking about the slope and a point. So point slope is super helpful. So let's plug in what we know for point slope. Y minus y1. So my y1 is here, because that's x1, y1. So we would have y minus 1 equals, and now I want the same slope as the red line. And the red line has the equation 2 times x. So it's got to be a slope of 2. And then x minus x1. And x1 would be here, negative 4. So x minus negative 4, that's going to turn to a positive 4. Remember, those signs change. So if x1 is negative 4, when we put it in the equation, it would be positive 4. So here is a possible equation. Let's just see if it'll graph it. It might not, and if it doesn't, it's okay. So another option, because I think I'm only going to graph one type of line here. I got to have it y equals mx plus b. I could distribute that too if I want it in y equals mx plus b. So y minus 1 equals 2x plus 8. Then I'm going to add 1 to both sides to get the y by itself. So y equals 2x plus 9. So that's another option. It's the same equation, just in a different form. So this would also work. There's one more option to find it. I just wanted to give you all. I think this is the easiest, but you could get this and then put it in y equals mx plus b. The other option is just to do it graphically. So I want to have a slope of 2, and I want to start at this point. I'm going to go up 1, 2 over 1. 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 There's the y-intercept at 9. It's 2x plus 9. So another way you could have got there using the graph. So 3 options. Point slope form, I think, is the easiest. You could put it in y-intercept form, or you could use the graph to get the exact same equation. So that's why the extension question was, how could you find the equation another way? Because there was 3 options. So use one of those 3 options on the cool down. Let me just skip ahead. So which lines are parallel to 5x plus 2? So it might help to start by graphing. Here's positive 2 up 1, 2, 3, 4, 5 over 1. So there's the line. We want to see which lines would be parallel.